doing this. Vanessa's question, and then I'll take all of yours. So it'll be nice. So just Vanessa wanted to go over isotopes again, so we can just do that. So isotopes, for Vanessa and anyone watching this later, or for Gwen, isotopes are essentially, it's a case where we are looking at the same element, but we are kind of looking at kind of one individual atom at a time. So normally, I mean, we've seen now with the idea of moles that there are really quite a few. Hi, good morning, Vanessa. There are quite a few, atoms in even a relatively small amount of mass of water. For example, 18 mils, about a tablespoon of water, is 6 times 10 to the 23rd molecules. So that's a huge number of atoms. But with isotopes, we're just looking at one particular atom at a time, essentially. And so remember that, like, kind of on average, we can choose an element. We can say maybe hydrogen has, we can say roughly 1.008 neutrons per atom, which is, I mean, a little bit absurd, right? You can't have a fraction of a neutron. But isotopes are kind of, we look at individual ones. So hydrogen happens to have 3 isotopes. We've got plain old regular hydrogen. This is most of hydrogen here. We have 0 neutrons in this one. Because remember, that number at the top is the number of protons plus neutrons. That's our mass number. Oops. That's our protons plus neutrons number. If we're looking at that, that's just kind of how we identify an isotope. One particular isotope has a certain number of neutrons and protons. And so if we kind of look at these, this one has 1 neutron, because all of these will have 1 proton. That's how we know it's hydrogen. And we just need to be able to have a word to describe these different individual atoms. And that word is isotopes. So, I mean, it's something we talk about kind of in the very beginning when we're talking about atoms, and then we pretty much never talk about it again. So it's really just a way of us to have a name for when the same element, one atom of it, has a different number of neutrons than another atom of that same element. So does that kind of clarify that, Vanessa? You are muted also, just so you know, Vanessa. So there's a little button on the bottom left that looks like a microphone. Or if you're on mobile, let's see. Let's see if I can see it on mobile. Because this is mobile too. Let's see. I guess I have to actually be in voice here, but I think it's also going to be kind of if you swipe, if you're using your phone. Oh, I see you're unmuted. Okay, cool. So, yeah. Go ahead.
And I was just confused. I was like, I knew he reviewed it initially, but then I'm like you said, I never heard it again. So I was like, oh, what is it? When I was doing the worksheet.
Yeah, exactly. It's something we kind of just put out there, and then we just never touch it again. So we talk about elements and ions all the time, but isotopes are kind of a less interesting thing. They're really only important when it comes to nuclear chemistry, because overall we just look at like 1.008. We don't really look at 1, 2, or 3, for example, for hydrogen. So.
Let me open the worksheet because I might have had another question.
Okay.
So for number 11, that's probably one of the ones that I struggle with the most. Where to calculate the charge of a chlorine ion if a chlorine atom gains an electron to become an ion.
Okay.
So on that one, what I did I kind of did the same layout of the chart that you gave us on one of the last 2 pages, where it had the mass.
I remember it was like there was like this thing, and then
so
all that.
I did that, and then I ended up with 16 electrons. So since it was still a positive number, I chose it a cation. I don't think I did the correct thing, so I just want clarification on that.
Sure, yeah. So chlorine has 17 electrons normally, right? It's got an atomic number of 17, so under normal circumstances, it has got 17 electrons. All right, so we can write this out. The chlorine has atomic number 17, which means that it has 17 protons. Normally, if it's neutral, that means also 17 electrons. And so you said in this problem it had gained an electron? Is that okay? So if it's gained an electron, we're going to add one, bring it to 18 total electrons.
Oh, okay.
Right. And then remember that the charge is equal to the number of protons minus electrons. And so for us right now, that's going to be 17 minus 18, which is negative 1. So with this, when you're looking at like positive, negative numbers, it really just is like, do you have more electrons than protons or less? And in this case, we have more negative things than positive things. We have 18 negative things, 17 positive things. So it makes sense our answer should be negative. Okay.
I think I was looking at it from a math point of view. I'm like, oh, if I have 17 and I lose one, that I
oh yeah, because I mean that's going to end up getting a difference of 1. Yeah. So if that case, you're looking at chlorine with a positive charge instead. Okay. So yeah, you'd have something like that. Okay. And I don't know if you just had to like put the ion or whatever, but it's Cl minus would be the answer there. All right. Gwen, would you like to ask a question? So you can kind of alternate maybe.
Yeah,
that's okay.
But I guess, you know, I think one thing that we went over, I guess, when we talked about moles, was it? I'm trying to think what lecture of it.
Okay.
On the practice test, I guess the ones that I seem to have the most trouble with was, just some of the, like, math problems toward the end about, that it seemed like they should be a lot more simple. Like 132, 33.
All right, let's take a look. All right, pulling that up. Okay, like 31, for example, or 32? You said something, one of those maybe? Okay. So 32, 33, I would have to give you more conversion factors. I think when I had this exam, I had put some like on the chalkboard in the classroom. So like 32 and 33, I would not expect you to do without me giving you the conversion factors. But 31, I think we can do right now because we already kind of know the conversion factors for 31. So that's a good kind of unit conversion problem. So let me just write out a little bit of information and then we can go through it. So okay, we're doing that 2 years. So we have time units here, right? We're converting between different time units. If we kind of just put out some time units we do know, let's see, we've got, minutes, seconds, days, weeks, months. I think that's pretty much it. I mean, if we could say decades or something, but that's going too far. So if we look at these, just kind of our general knowledge of time units that we have. So if we look at hours and compare that to years, whenever we kind of are doing unit conversions, it's a good idea to kind of choose a unit that's in between the two, if you have no idea what else to do. So like in between hours and years, we have a couple of options, right? Like these three could all be in between those, right? Those are all in between hours and years in terms of like their units. And so we kind of deciding then, we want to think, okay, do we know any of these units that we can convert easily between hours and years? Or are we going to need more units and we have to do like more steps? And hopefully it'll be like, oh, wait, okay, days, we do know we can go from hours to days. We know how many hours are in a day. And we know how many days are in a year. And so days would probably be a good unit to kind of go in between here. And I think that's probably our best one. But if we look at the others, weeks and months, I mean, it's going to be harder for us to say how many months are, or how many hours are in a month. Like, that's not really something we have on the top of our head, right? And also, like, a month is not really a standard unit of time anyway, because some months have 28 days, some have 31. And so that's a little less useful. Weeks we could do, but again, weeks to hours is, we'd have to, do 7 times 24. It's something, again, we don't typically carry around like a number that we're familiar with. So probably days is going to be our best bet in between here. And let's see how we can set that up. So if we want to maybe go from hours to days to years, every time, we kind of make a plan like this, we're essentially going to look at using one conversion factor per arrow that we have here. So this would be our first conversion factor here and our second one. And our first conversion factor has to take us from hours into days. And hopefully we'll remember, oh, that's right, it's 24 hours is 1 day. That number we do know. So that's going to be a kind of our first conversion factor. And then our second one is going to take us from days into years. And so we also know 365 days. We can assume a regular year, but technically, if we really want to be crazy, we could say 365.25, but we'll be okay with 365. Especially since it's multiple choice like this, like, there's nothing that's going to be super close that if you do 366 on a leap year, it's not really going to make a difference. Anyways, though, now that we have our conversion factors, we just have to arrange them properly. So we always start with the number that we're given, 486,500 hours. We have hours, so we're going to want to put hours on the bottom. And so with our first conversion factor, we have 24 hours and 1 day. That's this conversion factor here. And then we have our second conversion factor. That's going to take us from days. So again, I'm putting those on the opposite side. We keep our 365 with the days. And we're going to have our 1 year. And that's how we're going to do this. So we're going to make sure our units cancel out. So that means something's on the top, something is on the bottom. And that should do it. And so now it's just the math part. So what we're going to do, we bust out our calculator and do 486,500 divided by 24 divided by 365. And you get, I'm not going to round it, but 55.536529, whatever. You get some long number. And so then kind of our last step is rounding with sig figs. So if we look at number 31, we have two answer choices that are this answer, right? We have 55.5 and 55.54. And so those numbers are numerically essentially the same, but if we want to think of sig figs, we have to now look at our original number. And we'll see that this one should have 4 sig figs. And so we need to round this one to 4 sig figs. So we should round this 1, 2, 3, 4. So 55.54 will be our answer there. So there's kind of two parts to this one. We had to kind of do the unit conversion and then apply sig fig rules. And that was kind of the tricky bits to this one. Does that kind of clarify that a little bit?
Yes, thank you.
Cool. And again, like 32, 33 would be similar. They would just have, I would have to give you some conversion factors because I don't need you to know pounds to grams. There's no reason for you to memorize, or horsepower to kilowatts. Like, forget it. You're never going to need to memorize that at all. But something like time units like this, I would probably expect you to probably know already. Like, I wouldn't expect you to know hours to weeks, but yeah.
That's a question, Professor.
Sure.
Will you specify on the answer, on the question, if you need 6 figs, or do we...
Always apply sig figs. Always. Yeah, always do sig figs. Usually, most of the questions you can see will have either the same number of sig figs, or it's the same number with different numbers of sig figs. So it just depends if that question I'm really focusing on sig figs or not. Let's see. If we take a look at, for example, number 7 on the first practice exam, it says it's 100 with a decimal point times 22.00. I mean, obviously the math is not hard, right? It's going to be 2200. But that one's like definitely a sig fig question, right? And with this one that we just did, this unit conversion, we had two answers that were very similar, but the difference was the sig figs. So yes, you will still always want to apply sig figs. That's kind of our short answer here. But you'll see some questions are like number 28, everything has 3 sig figs there, so like it's less relevant, I suppose. And like number 33, also everything has 3 sig figs, so like it's sometimes it's going to be more important than others. I'll write that down just in case as well. So we're always going to take care of sig figs in everything that we do in this class that involves measurements of any sort. So. All right, let's see. That's not a question for this. Okay, yeah, it's interesting. No one posted questions except for you, Vanessa, and then Gwen had emailed me about wanting to do this. So, I'm surprised not as many of your fellow students want to ask questions, but whatever, maybe they can't make it. So, I'm gonna just scroll up in our general channel if we have any more kind of questions that are. Let's see. No, I don't really see any others. So, do either of you have any more questions that you'd like to go over, or just general anything, or anything on like the homework questions or something?
I do, but let me just scroll through my stuff.
Yeah, go ahead. Gives me time to savor my coffee, so I'll appreciate it. Oops.
Are you going to give us questions from like the periodic table?
Can you be a little more specific? Like any example of? Sorry, say again.
Like on the first practice test, I see that there's like a few that involve the periodic table.
Like number 13, for example, or 12.
And 22.
22. Okay, 22, that's not one we need to have for this exam. That one is when I would have students memorize their polyatomic ions by this exam. I don't need that for you guys, so you don't have to worry about 22. But for periodic table, what I would say that you need to be able to do is 12 and 13. Like those would be examples of questions that would be kind of relevant there. Welcome. See who we got. Aaron. Okay, welcome. So yeah, 12 and 13 would be types of periodic table questions. I'm not going to be asking you something like 22 because that's not for us right now. Let's see what else we have.
Would you be able to explain number 12?
Yeah, sure. So that part has two questions, or two like bits, right? So with the periodic table, I think we actually just went over this. Did we just do this yesterday? So maybe it's not even on this exam. Got it. So now that I think about it, I think this one we did yesterday, because I know we talked about it, but I think this is something from yesterday. But suffice it to say, on the periodic table, here we go. I don't think I've got anything like this on yours. on your exam because this is now chapter 4. I think I was using a different textbook when I wrote this exam, so it's a little bit different. But anyways, suffice it to say there are columns in the periodic table, and there are rows, right? 3, 4, 5, 6, 7. So when you do watch the yesterday's, we're going to see that the numbers at the top those are called groups, and a few of them have special names. In this particular question, it says halogen. Halogens are group 7, or 17, sorry. So those are group 17 elements, which are going to be kind of this column here, the like second to the last column on the periodic table. And then it says also period 4, so that means it's the 4th row. So then we're looking at whatever element happens to be right here. And if we just pop over to our periodic table, stop asking me to buy it. Okay. We're looking at group 17, so that's this column here. And we're looking at the 4th row. So helium is the 1st row, the neon, argon, krypton. So that's our 4th row, but we're looking at this kind of green column here. And so the answer is going to be bromine. So I don't think I have this actually on your exam 1, but it's something I guess we just went over yesterday. So hashtag deleted channel. What is Miriam writing?
And he also told that oh, it's a deleted channel.
Which one's a deleted channel? That's weird.
The one that had the review.
This one? Oh my gosh, is it really?
When I had tagged that one and right now I entered, yeah, it's a deleted channel.
How hilarious. I had no idea. Let me just see what this looks like. So this is so like wow. Okay, I'm gonna just post it and then I'm gonna click it and we're gonna see. Okay, it's working now. For me, but maybe the first time I did it. One sec, let me just type to these people if they want to join us in chat. Okay, so there we go. So I guess we can go over Miriam's question, since she wrote it. Can you reveal the solution on how to find number of electrons? Okay. Cool. We can do this, I suppose. It's a kind of a hard question because I don't quite know what she's asking, but we'll try. We'll try it. So, how to find the number of electrons? Okay. So, number of electrons normally, if your atom is neutral, for whatever atom it is, your number of electrons will equal your number of protons. So whatever your atomic number is, you'll have that many electrons if you're a neutral atom. And so it just depends. If you are a positive ion, that means you have the number of electrons is going to be lower than the number of protons. If you are a negative ion, it's going to be bigger, more negatives than positives. But a better way to do it is to just remember that charge is the number of protons minus the number of electrons. So you don't have to worry about this business if you can just calculate the charge this way. So if you have something that has like Cl2 plus for some reason, you could say, okay, the charge is +2. Chlorine has, oh, I swear we just did this. Where was chlorine? 17, I think? Yeah, 17 normally. So chlorine normally has 17 protons. And if we're finding the electrons, that's what's missing here. So we can add electrons to both sides, subtract 2 from both sides, we get 15. Just remember, if you are positive, you have lost some electrons, you have less electrons than protons. Fewer, I suppose, is the correct word, but whatever, we're not grammar people here. If you're more negative, that means you have extra electrons. So positive means you're losing electrons, and negative means you've got some extra ones there. So that's how you can deal with kind of correlating charge with the number of electrons. So hopefully, Miriam, when you watch this, that'll answer that question.
Got a question.
Yeah, what's up?
Can you explain the difference between the atomic number and the mass number a little bit? Because I was having a hard time with that on the homework.
Absolutely. So we can do atomic number first. That one, if we take a look at our dear friend chlorine, since that seems to be the... if you look at chlorine on the periodic table, it'll look something like this, right? You'll see a big 17 at the top, a Cl, and then a number with a bunch of decimals. For chlorine, that's 35.45. Maybe there's more depending on your periodic table. This number up here is your atomic number. So that's the number of protons in every single atom of chlorine. So this is also the number of protons. So each element is defined by the number of protons it has, so every single chlorine must have 17 protons. This number down here, a lot of students do get it confused with mass number. I'm going to just describe this one first before I talk about mass number. This one is atomic mass. So a lot of students on that, remember that chart that we had for the homework that had like 40 potassium and write out all the mass numbers and all that stuff?
Yeah.
So that one, a lot of students will write the atomic mass for it. That's not correct. So the mass number is for one specific atom. The atomic mass is for all of the chlorine atoms that exist. Like, it's the average. So that's the average mass number, essentially. It's a little bit more, like, kind of distinguished, but as you see here, we can have decimals with atomic mass. Mass number can never have decimals. So let's talk about that one now. The mass number is equal to your number of protons plus your number of neutrons in a single atom. And so this must always be an integer. You can never have a decimal for this. So for chlorine, let's say chlorine comes in a couple of isotopes. We've got chlorine, actually that's 35.45 now that I think about it. We have chlorine 35 and chlorine 37. These are the two main isotopes of chlorine. Those numbers up there are the mass numbers. And the only kind of purpose for the mass number is to help identify an isotope.
So how do you find the number of neutrons from that atomic number? Because it doesn't
Yeah.
give you any indication.
Indeed, it does not. Indeed. So we do kind of usually we'll write our here. I'm going to keep those here, and I'll just work on one of them. So if we're looking at chlorine 35, 35 is our mass number, right? We also know that it has an atomic number of 17. So mass number here, go ahead.
Are you basically just going to subtract
That's all you do, yep.
the isotope number from the atomic number, and that gives the amount of neutrons?
That's exactly right.
Okay.
Yep.
All right.
Because mass number is protons plus neutrons. So if you do that minus your protons, right? Protons minus protons, whatever number that is, you just get neutrons left, right? So that's your mass number here. So, and that's your number of neutrons. Okay.
All right, that was very helpful.
Awesome. All right, who haven't we got yet? Okay, we've got Jesse who's got a question. Jesse, actually, that is for, that's for 111. let's deal with that at 10 or at 11 o'clock if we could. Just because I want to focus on 101 for right now. But we can definitely do that question. So if you could, can you just copy paste it into 111's chat? And if you want, actually, I can. Do you want to stay in this? Do you want to stay with this role? I can just put you in 111. I guess it doesn't hurt for you to be here because some of the material is the same. So cool. Alrighty, let's see. Who else do we have? How about Aaron? Do you have any questions you'd like to go over? And then we can go back to Gwen and Vanessa. Aaron, I don't know if you know this, by the way, but you are muted right now, so I don't know if you're like trying to ask anything. But in the bottom left, there's a little microphone icon, or if you're on your phone, you kind of have to swipe to get to it. But you'll see there's a little microphone button. You can click that, and it'll let you talk again, if you want, or if you're just here listening, that is just fine. So. Alrighty. Okay, well, we can take a different question then, from anyone. Vanessa's got one. Oh, about 30, give or take. So, yeah, thereabouts. I think actually I can look it up.
From 1 to 10, how hard is it?
This one is generally the easiest exam of the 4 exams you'll have. Or I guess 5, including the final. Let me see how many questions I've put on this. 30 questions, yeah. All equally weighted. Go ahead.
Is the test, like, or do we just print it out and then just send you the PDF? Or is it like an actual, like, multiple choice?
Yeah. It'll be like a multiple choice on Canvas. So you'll just go on Canvas. It'll, what I can do, let me put like a fake one. And that way y'all can just practice with it so you can get used to the format. Go ahead.
Go back and forth, or
you'll have all the questions at once, so you can answer the whatever order you like.
Final answer.
So you're kind of cutting out a little bit there, but you're going to have all the questions visible at once, so you can move around however you like through the exam. And so, yeah. Let's see. I'm going to just make it. Okay, so I'm going to just put like update question. Okay, and then I'm going to put one more question. Some of these random things it's telling me to, it's suggesting that I give as potential answers are really funny. So I'm putting up a fake little quiz now that you guys can kind of see the format of. Okay, so that should be there. Let me publish it. Okay, so I'm going to put this in your exams module. And let's see here. Okay, so if you go on Canvas, actually I can show that screen. Okay, so here we go. I'm gonna switch screens on us real quick. Change windows. Let's see. Okay, so hopefully y'all can see now this. So I'm gonna just I'm on our Canvas homepage. This should be what you see. This is our practice one. I just put 2 questions and a 10-minute timer. This is what it's gonna look like. So you're gonna have your timer on the side here. You'll be able to jump 2 questions I mean, there's only 2 questions here, so there's not really any jumping to do, but you would, choose your answers as you go through it, and at the end you click Submit Quiz, and I got 0 out of 0. Lucky me. Oh no, I chose the wrong answer for number 2. And yeah, so I don't think you'll be able to see your answers right away because I have it to open up on Tuesday or something, just so you'll have your score, but you won't be able to see what you got wrong until the next day. Okay, and that's just kind of what it's going to look like. So something like that. Okay.
So what resources are we allowed to use during the test?
Anything non-human, I suppose. I have no way of controlling it, so you will use whatever you feel like using. So, I mean, yes, that means you can use the internet. You can use your book, your notes, anything that's not a classmate or other human, I suppose. So.
Just know that Google is not.
Yes, Google, I mean, it's hilarious how many times Google gets things wrong, especially when it comes to nomenclature. Although you guys have not talked about nomenclature yet. We'll do that, I think, next week. But yeah, Google will give you wrong answers.
And
Oh, Vanessa, I'm sorry, I just cannot hear a single thing you're trying to say right now. Out of curiosity, is she, I can hear you again. Okay, cool. Okay, I heard the last sentence. Sorry, Vanessa. I don't know why, something's robotic about it, but yeah, sometimes you'll want to choose. I figured there's probably some internet problem, but yeah, it's I think the gist of that is absolutely correct. Cool. Alrighty. While Vanessa's typing, any other questions we'd like to go over?
Can you review how to write out a symbol like number 23 on the practice?
Sure, let me pull that up. 23. Okay. Okay, let me go back to Canvas. Okay, practice good one. Okay. 23 is symbol for, okay, sure. Okay, so we have, we've got 20 protons, 22 neutrons, and 18 electrons. So, with looking at a question like this, we're asking to come up with the symbol. First thing we probably want to do is figure out what element it is. Oh my gosh, I think it says the answer choices there are obviously mistakes, right? Because I think when I had generated this exam, the symbols that I had put in came out all real funko, super weird. So I just changed them to just choose B. But we can go over this to do a real question. So first thing you want to do is figure out what element it is. And that's going to be from the number of protons, right? So that's a good kind of first step. So let's go ahead and figure that out. So we're looking at protons number 20. So that's calcium then. So we're looking at this because the atomic number, the one on the top left, is calcium. So that's what we're looking at here. So we know it's going to be Ca. That's the first bit. And if we can write the 20 there, that's good as well. So remember, we have kind of a lot of information here. We have the atomic number, the number of protons. We have the mass number. And then we have the charge. These are all parts of the symbol. So we have our protons. We now have two other things to look at. We want to look at the mass number, and then we want to look at the charge here. So remember, mass number is protons plus neutrons. So in that case, this will be 20 plus 22, which is 42. So that's the number that's going to go up there. And then, so we have now almost all of our information. The last thing we have to worry about is the charge. The charge in green. The charge is protons minus electrons. And so that's going to be 20 minus 18, which is positive 2. And with this, I usually do indicate the positive because that does matter, right? So, and then we would write that 2 plus. So remember, we, for whatever reason, switch the plus and the 2. That's the way the chemists work. So that would then be our kind of final answer for that one. So it's a matter of remembering all of the information that goes into a symbol and then figuring out what some of the unknown ones are. Alrighty. It's funny, this guy's cats are watching the stream. That's hilarious. Alright, any more questions we'd like to go over?
Will the worksheets help us study, right? Or would you recommend?
I would say yes.
More?
So, I mean, I'll kind of do this maybe in the order of depending on how much time you have. So, I'll kind of write it out. So, what to use to study? This is a good, a good question. I would, number one, is do the practice exam and grade it, and like kind of grade it, and then kind of understand or ask why things weren't correct, because the key is up as well, right? So you want to go ahead and look at it, at your answers, and do that. I would also suggest that you do it under kind of timed conditions. So like practice it as if it's the real thing. That was probably going to be your most bang for your buck. But since there's only one practice exam that I have, normally I have written exams, so multiple choice ones are harder to write, and so I don't have many practice ones of those, unfortunately. Okay, so then I would take a look at your homework and answer keys for those. That would be kind of the next step, is making sure, okay, did I understand every question I did? Did I get everything correct? on the homework when I look at the answer keys. Do I understand if I got something wrong, why I got it wrong? That would again be the kind of the next step. And then the third step would be maybe kind of review your notes. So maybe kind of, if there were like important concepts, like make a like condense your notes down to one page or something where you're putting all the most important information. Because you can use, notes on your exam. Again, the only problem is that takes time away from you to like look stuff up. But with that, if you condense everything down to one page, it'll be easier for you to reference. Like if you make a single cheat sheet, that's kind of a good idea. And then let's see. After that, then I would start kind of read the chapters or like rewatch the videos. So that would kind of be that would probably be the order I would do these things in, depending on how much time you have. Okay?
I have another question.
Uh-huh.
Once you test us on, let's say that you already tested us on lectures or chapters 1 to 3, will we continue to see stuff from those chapters in future exams, or once we test our knowledge in those, is that pretty much not seen until the final?
Okay, yeah. Good question. Some of it does remain, some of it goes out the window. Like this business about isotopes, for example, will not be seen again until your final, probably. Stuff like identifying matter, not really. The unit conversion and sig figs will be with us the entire semester. Those two, like chapter 2 material, will certainly follow us through. Because we'll see, most of chemistry is doing unit conversions. So, that's the most important one. For chapter 3 stuff, isotopes, no, we're not going to really look at number of protons again either. We're looking mostly at electrons. Like chapter 4 is all about electrons, right? So we are going to deal with electrons and charges still, but not really the rest of chapter 3. We're not going to worry about empirical formula again, or mass percent, or things like that. But knowing how to convert to moles will be important. So it's kind of here and there. But you'll see as we go through the next chapters, like chapter 4, we're not going to need moles, but actually we're not going to need moles again until, I think, exam 3. But you'll know as we're going through like a new video, like if we're using moles, then we'll keep using it. So, but some of the stuff, yes, we will not see again until kind of our final exam.
So is the final exam cumulative?
Yep,
Cumulative?
it is. Yep. And how that's gonna work is, I think, the way I've written that, it's going to focus on the last chapter. So maybe 20% of the exam is the last chapter, and then the other 80% of the exam is equally divided around the rest of the class. So it will be cumulative, yeah. But I'm not going to be asking the most obscure, least relevant, random things. I'm going to still try and focus on the major topics we've got. I actually have kind of a study guide thing. Let me see, do I have that up here? Let me see if I can find it, because it's got essentially the major topics. I wrote this as kind of a list of learning objectives way back when. Let me see. Give me just a sec while I look that up, but you can ask more questions in the meantime. Okay, let's see. Do-do-do. I thought it was. Okay, maybe it wasn't that one. Aha. Yes. Just so you know, I'm going to share this document on our Canvas page. The chapters are going to be completely all over the place because we have, this is from an old textbook, but the order that, like, okay, I'm just going to put it up first and then I'll talk about it. I don't want to like get things confusing. Where shall I put this? I'll put it under course info. Okay, so you'll see under this, I can maybe change the name, yeah. Okay, on Canvas, I'll switch back. I'll switch that screen over to Canvas real quick. Change windows. Okay. This document here, the learning outcomes, again, it was for a different class. I mean, it's the same class, but different, like, textbook and things. You see how it starts, like, 2.1 and stuff? If you follow these, like, 1.1s, like 1.1, 2.1, 3.1, that's where we've gone here, essentially. We've covered 3 chapters worth of material. And so it's these first 3, although they're just kind of in different, like, orders. Let's see if I can, like, make this not so tiny, but that's the idea here, is, like, these are the goals I want you to be able to do. These are the skills I want you to develop from these kind of things. Again, the chapters are not going to correlate. They might, but this is for a different one. So, like, determining the number of sig figs, converting between units of the same unit, base unit, like centimeters to kilometers, memorizing some metric prefixes, scientific notation, converting between Celsius and Kelvin, conversion factors, classifying matter, identifying things as physical changes or whatever, calculating mass number. So these are kind of the skills I want you to have. So if, again, like nothing else, learn these things for your final exam. So, okay. Alrighty, we got time for maybe one more question. Alrighty then, we'll go ahead. I'm going to go ahead and upload this onto Discord for us, the notes here. And yeah, if anything does come up, just throw it in the general chat here, and hopefully people can help you out. I should be able to pop in here and there as well, but I have so much grading to do this weekend. It's just ridiculous. Okay, C101, yes. Alrighty. Hopefully this was helpful. I'm going to go ahead and stop the recording as well.